It's a good hobby.
We're live.
Welcome to Space Place Canada for the 2nd of April 2024. My name is Charles Ennis. I'll be your host, and we've got a great show for you tonight. Before we do anything else, I would like to gratefully acknowledge that I am joining you today from the traditional territories of the unceded lands of the Sechelt First Nation, where I observe the skies. I'd like to express my concern and support for the people of the Sechelt First Nation. And you may be joining us from another part of Canada or beyond. And we've people here today from across Canada, which is home to many different diverse nations, Inuit, Métis, and Indigenous people from across Turtle Island. So I encourage you to learn about more about the history of the land and the people in your area. We recognize the significance of these lands to Indigenous peoples, past and present. And as we engage in astronomy here, we respect, learn from, and honor the deep relationship between Indigenous people, the sky, and the Earth. So, if you are new to Space Place, let me tell you about their mission. It's to bring an iconic 21st century public planetarium to Toronto and a virtual planetarium to Canada within global reach to serve local community, educational, and tourism needs to promote awareness of Canadian space and STEAM successes and opportunities, and to promote online curriculum-based STEAM program opportunities for underserved communities, spotlight educational prerequisites for employment prospects in space and on Earth in a wide range of occupations. We're a registered charity with a multidisciplined leadership team of professionals, including educators and senior advisors who are planetarium experts, partnerships with post-secondary institutions, including Lassonde Engineering at York University and their K2I program with a view of developing collaborative online and in-person programming. And Space Place has active members, volunteers, and contacts across the GTA, across Canada, and across STEAM fields, many seeking to be engaged in content development and mentorships. We rely on your support. Donate what you can. We're fundraising to support our programming, outreach, and technical evaluation of prospective sites for the planetarium. Our current fundraising goal is $25,000. Renew your memberships and add a little extra, maybe $50 if you can. If you'd like to join Space Place, email us at chair@spaceplacecanada.ca and we can send you the information. And if you donate $100 and more and can arrange to pick up an envelope at 30 Wellington Street, East Toronto, a limited number of Eclipse classes are still available for the Eclipse coming up next week. Please specify how many classes, maximum of 10, and a day of pickup from the 24-hour concierge. Classes can no longer be mailed. We don't have time to get it to you that way. Now a message from MDA, one of our sponsors. And there we go. So tonight we have a great presentation by Emil Karnick, CEO of KA Imaging, and Adam Greif, the COO of Canadian Space Mining Corporation, delivering medical services in space and on Earth. And just to quickly introduce these two, in the order that they're going to be doing their intro presentations, Adam is the COO, as I said, of Canadian Space Mining Corporation, an infrastructure company solving long-term problems for space and immediate challenges here on Earth. He brings a diverse background from leading cloud computing and autonomous vehicle companies to managing the operations of complex health services and space systems. Prior to CSMC, Adam helped lead commercial and partnership strategies for ClearPath Robotics, having joined as one of the first employees in helping to scale the company to sales of thousands of autonomous vehicles across more than 40 countries. 2018, Adam joined the Assistive Technology Clinic, where he led an interdisciplinary care team through transition to virtual care for over 4,000 patients during the pandemic. Adam joined CSMC in 2022 to lead business development and operations. CSMC believes that the unique constraints of space can breed innovations for addressing Earth's most pressing challenges, and he's passionate about realizing that vision. Amal is a seasoned executive in the medical device industry. His experience covers the whole spectrum from startups, ultrasonic, Sentinel Medical, Ventripoint, to large OEMs, GE Healthcare. Entering into the profession with a bachelor's in engineering from the University of Waterloo and a master's in electrical engineering from McGill, he spent 20 years in the medical imaging space to become a leader of multiple disciplinary teams, sales, engineering, and operations. He is now posted to steer KA Imaging into a position of global leadership. Let me stop sharing there. Welcome, gentlemen. It's great to have you both here.
Thank you, Charles.
So, Adam, I understand that the way we're going to do this is you're going to start with a short presentation, and then that's going to be followed up by Amal. And then if people have questions, please put them into the chat, and they will be directed to me by my person in the background, and we'll do our best to answer them all for you. So take it away, Adam.
Sure. Is everyone seeing are you seeing my screen okay?
Looks good.
Okay. Yeah, thank you so much, Charles, for the kind introduction. I'm Adam Greif. I'm the Chief Operating Officer of the Canadian Space Mining Corporation. So CSMC, as Charles mentioned in my introduction, is an infrastructure company that solves long-term problems in space by first solving immediate problems here on Earth. One of my philosophies and one of my beliefs is that the road to the moon and architecture for the moon runs through the Arctic. What we've seen at CSMC is that almost every technology that we develop has implications for helping Canada modernize its Arctic infrastructure, whether that's for Indigenous communities, industrial operations, or defense applications in that region. Technologies that are being developed for space have meaningful implications for Canada's Arctic and our national interests and strategic interests as a whole. So we focus in three areas: in resource utilization, energy, and of course, healthcare, which we're here to talk about today. So here's a quick video about our healthcare applications.
Technology designed for space has a long history of benefiting life on Earth. From the GPS that you use to find your way around to the Velcro on your kid's shoes, space technology has enriched the fabric of our everyday lives. But technology for space shouldn't just be for the future. It should help solve today's problems, like healthcare in the most remote parts of our country.
With the financial support of the Canadian Space Agency, CSMC has developed a purpose-built, medically customized capsule that will deliver care to the most remote corners of Canada and beyond.
As humans extend our reach into the stars, Canada wants to become the global leader in space healthcare. The Connected Care Capsule is a prototype that will be used here on Earth as a capability-building exercise towards the creation of a hospital that can function on the Moon or Mars. CSMC is an infrastructure company focused on solving big challenges in space by first solving problems here on Earth. And when we can deliver care in places where resources are scarce, we are paving the path to deliver care beyond our borders and inspire the next generation of Canadians.
So that's our quick piece of marketing on our healthcare project. So the Connected Care Capsule C3 is a $2 million project funded by the Canadian Space Agency to develop an advanced, rapidly deployable health capability for remote and extreme environments. So that was the project that you saw in that video. In addition to our healthcare portfolio, as I mentioned, we're doing resource utilization. So CSMC is leading all of the work for the Canadian government in situ resource utilization. We were contracted to do an end-to-end concept for an operational lunar mining site, and have progressed that forward into some strategic technologies that we're developing in order to help close the gap and develop iconic contributions for Canada in that area. On the energy side, we're one of 5 companies in the world that are funded to develop a micro modular reactor for use in the lunar environment. So that's a micro nuclear reactor to deliver heat and power to remote areas. And again, the overlaps with the Arctic are fairly substantial, where we can deliver this to Indigenous communities who have inequitable access to heat and power currently, which is absolutely critical to ongoing quality of life in the region. And then again, coming back to our healthcare, so the Connected Care Capsule C3, which we're here to talk about today, and our partners KA Imaging, who were a critical piece of the technologies that we included, all specialized for working in as transportable systems that can be rapidly deployed at low cost, low power in remote regions where this type of equipment is needed most. I'll leave it with our favorite slide of the presentation: make no little plans, they have no magic to stir our blood. This is a quote we live by at CSMC, and for anyone on this call or any of your friends for whom that resonates, let us know. We're always looking for more people to help join us in our mission.
Great. Now, Emil, you've got a short presentation for us.
Absolutely. Thanks, Adam. We love being part of you guys. You guys have been fantastic, and what you guys are doing is really revolutionary as well, and setting a great stage to see how you get to space and making sure we take the right technologies up into space as well. Can you guys see my screen now?
Yep.
Fantastic. So again, my name is Emil Karnick, President and CEO of KA Imaging, and one of the founders as well, co-founder. And what we've done is create what we call spectral X-ray, or color X-ray even. And you may ask, why are we doing this? Well, X-ray has been around 120 years. The fundamentals of X-ray, though, if you go to the doctor today, that same X-ray you get is essentially the one that Röntgen created about 120 years ago. The fundamentals really haven't changed. They went from film to digital, just like your camera, but the fundamentals didn't change. And I'll give an analogous, if we take an intensive care unit patient, so an ICU patient, they've got a lot of lines, tubes. They're difficult to transport. You get them trying to move all this stuff gets really difficult. So if you need to take them for advanced imaging, like CT, for example, computer tomography, it can get very challenging, very costly, require a lot of human resources to move that patient. So we were looking at how do we make better imaging at the point of care where it's needed without changing today's technologies or today's workflows, probably. And when you think about space, trying to get up into space requires a big payload, or, increasing payload becomes a challenge. So you don't have a lot of advanced imaging in space. You've got most likely X-rays. So how do we improve X-ray? So what we did is we created what we call color X-ray at times, because like your eye can see 3 colors and create this amazing color world, we've created an X-ray receiver that splits the incoming X-ray spectrum into 3 different energy bins. These 3 different energy bins now allow us to understand and separate images. So we can now say, look, here's your standard X-ray. Now we want to see, let's say for the chest example, we want to see the image without the overlying rib cage. So what we've proven already is that we can now take away the ribs, look at the soft tissue, for example, the lung field, and see pneumonias, pneumothorax, cancer better, for example. Conversely, you want to now see the bones or dense images, we can see lines and tubes really well. We can see fractures better. We can see calcification in coronary arteries. We've also seen the capabilities of lesions hiding behind the heart. And so we've really shown that the technology has proven itself clinically that we can now take our innovation to the bedside. And here we're using the bedside as an example for extending into space as well, because we don't change the weight. We use the same X-ray radiation. We use the same weight. It's portable. It's battery operated. So it makes it easy to really move around. And when you think about computer tomography or CT, they're very accurate. They're a great 3D modality, but it's not very portable. You can't really take it in space. It's very expensive. It's very heavy. So what we are is really a bridge between standard X-ray, which is lightweight and accessible and available everywhere with low radiation and low cost, increase that capabilities, and even shown with data that we have reduced the number of CTs required in the intensive care unit. Again, synonymous to trying to go somewhere where you can't always get another advanced imaging. And this was just for very, very sick patients. So we know when you take it out into space, it will, of course, be much better as well, because you're not going to have as sick as patients, maybe some injuries, some minor pneumonias potentially, but there's a lot of opportunities we see. So thank you for listening to us, and we look forward to the questions.
All right, thank you. The first thing I'd like to know, this is something that you are going to be putting on the moon and probably ultimately Mars, but is this something that could then be put into space, say on a space station like the ISS, or one of those stations that's going to replace that ultimately?
Oh, absolutely. We look and feel like any other X-ray system. We just provide better outcomes and better data. And when we say data, it's the images in this case. So we provide better data, makes it easier. And of course, we're developing AI alongside, because you don't always have, let's say, a radiologist who can read these images when you're in rural parts of even Canada, frankly. You don't have people working there. And that's where, Adam and us, we've been working on this together. How do you take those images, bring AI into the picture, and plus make it distributed, frankly?
So somebody down here on the Earth could be diagnosing somebody up on the moon.
Absolutely. That's what I said. Adam and their teams have been creating a lot of those connections.
Yeah,
I
I'll add on to that. There's a roadmap for delivering healthcare in space, as there is for any technology development. So when we first started with C3, we first did a scan of the market to see what was available for remote healthcare and virtual care. And one of the gaps that we identified was the health telemetry that you need for specialist care, right? So and when we started talking to Indigenous communities in Canada, our partners over in northern Canada, we heard a lot of stories about strokes being misdiagnosed or major medical events that didn't need to become chronic or fatal, just because of a lack of access to the data that you need for specialists, and access to those specialists. So it became clear to us that one of the major gaps was, how do we get richer data that could be used by health specialists in order to make that more accessible to vulnerable Canadians. Long term. So this is now become a more advanced version, a more sophisticated version of virtual care. But of course, long term, you need to move some of those things. One on the moon, that's fine. We can work with doctors here on Earth. Once you get to Mars and you have the communication delay 45 minutes or longer, then you're really reliant more on artificial intelligence to start making some at least triage diagnoses and advise on medical care. So I think what we do is we see this progressing and keep iterating on these technologies until we get to that point.
That fits right into what one of the people are asking here. They're saying, are doctors needed to operate this imaging tech, or could these be used by a technician or other medical personnel?
Oh, absolutely. It doesn't need to be used by a doctor. It can be used by X-ray techs, people trained to take an image. That's the one thing that's nice about X-ray. it's less operator dependent. You can sort of point and shoot,
Mm.
just like a camera. Maybe not quite, but similar concepts.
We have someone here saying, what exactly is inside the C3 medical shipping container in terms of equipment?
I can't tell you everything. I can speak in kind of broad strokes. So it's a combination of vitals assessment tool, so standard fare things that you might see when you go into an emergency room and a nurse is triaging you and reading your vitals. A couple of other smart devices that go on top of that. Advanced medical imaging technologies like K imaging, color X-ray system. And then also rehab technology, smart rehab technologies. So all of these things are connected through an advanced IT system to centralize the data, and so that it can be viewed from anywhere in the world by any health provider who needs to see it and advise on the care. And when it comes to things like rehab technologies and imaging, like these are things that aren't traditionally integrated together into a single data source. And it allows the care professionals to both assess and diagnose what's happening with the medical event, provide immediate care and stabilization if needed, and then also track and monitor kind of their progress long term, maintain healthy, like to the benefit of long-term health outcomes. They can keep visiting the container using the rehab equipment, and then care plans can be adjusted, and all this is being done from hundreds of kilometers away. There's some support tools in there too, like a 3D scanner and a 3D printer. We're partnered with other organizations that can do almost near real-time 3D printing of casts and braces and things like that. These are resources that remote communities just don't have right now. Things that we take for granted in the general population of Canada.
There's a question here. How could this technology be used beyond healthcare? I know, Amal, you had an answer for that.
Yeah, absolutely. So our technology, as fundamentally what we're doing, is doing material separation and material understanding. And that's not just limited to healthcare. It can be used in other non-destructive testing, we call them, or industrial imaging. And one use case is, special materials. What kind of materials are you looking at or investigating? And when you look at the space station, for example, IIS, it's got a lot of different composite materials around. And when you blend some composite materials, you want to make sure that they have uniformity. So because we can see different materials, we can pull them apart when we take the X-ray and see how well it's distributed, for one, but also X-rays used to investigate, let's say the IIS gets hit by a foreign object or a floating object or something out there. You want to investigate the damage. You can use X-ray at that point to better understand the impact, literally, unfortunately, of what hit, and see what's going on.
Wonderful. What kind of material would a shipping container potentially be in space? Somebody's asking. You're delivering a package, and I guess what they're asking is, are you delivering the container for it as well?
There's a lot of benefits to doing it in a container. We can kind of manufacture it on a line. It helps with scalability and kind of maintain a consistent experience as we get to hundreds or deploying thousands of these things. So it allows us to maintain it and provide a certain service standard as we go forward. But obviously, it's not going to be a shipping container that goes into space. I don't think it would survive the vacuum conditions or the radiation. So we would either adapt it to better known materials like what they use on the space station, like aluminum, specialized aluminum hulls. There's some talk now about inflatable designs for station modules, which are being tested by Space frequently now. So or we just take the technology and we adapt it to the commercial space stations and kind of help them build out their med bay. It's more about the technology stack than the container that it's in. Even though one of our core philosophies here is that it's rapidly deployable. So whatever helps us make it rapidly deployable for the moon, for the stations, for Earth, those are going to be opportunities that we explore as we scale up.
Okay. Louis here is asking, is any work being done with Cloud DX or Theralaze technologies?
Cloud DX is not something we're working with right now, but it's very similar to what some of the software that Adam's been working with as well. it's a hosted platform where you can transfer images. Therlace is my understanding, it's photodynamic therapy, PDT. And so that uses a light therapy. And I'm not sure what wavelengths they use for that, but X-ray is not invisible light. So it may or most likely wouldn't work with them right now. We haven't tested it, but if it's using visible light or near infrared light, it would just be a different wavelength than what we're working at.
Okay.
We also have not experimented with it yet, but we are open to technologies as we continue to scale. Whatever helps, drive the patient outcomes is really what we're concerned about. And we don't know all the technologies that are out there. We haven't seen them all. So if you have any, feel free to bring them to my attention.
So Tom, you're saying, is it reasonable to assume one doesn't need to ship up a whole container all at once? That is, incrementally add or replace components rather than heavy lift to bring it all up in one launch?
Yeah, I think there are different strategies for deploying infrastructure in space, technologies in space. Space stations are built in modules. I think what's likely is that this would be shipped as either pre-built into a module with other things in the module. So, if it's a multi-purpose vessel, then it would be a part of that, or it could be shipped up, as as an isolated module itself and attached to a station or deployed in the lunar environment, or it could be shipped up in pieces. I don't know that I think you're looking at really mass and like weight and size constraints for things that you want to ship up in pieces. I think the compact nature of the and the weight of the types of systems that we're using in C3 lend themselves well to being all launched in one package and deployed as one package. But yeah, I mean, if that makes sense, then we obviously do that as well.
Okay, someone's asking, how close are we with this type of hyperspectral imagery and data sets to be able to have a fully enclosed diagnosis module like seen in movies like Elysium?
Great question. I'd love to say very close, but probably still a little further away. Interesting enough, we are using our technology to extend it to beyond just one chest X-ray, but scan a person to get a 3D data set as well. Not quite like a CT, but something that can be done very easily as well. So I think there's a lot of opportunities that we're going to see more and more advances in healthcare and healthcare imaging as technologies are advancing as well. Because in imaging or in healthcare, as you get more advanced technologies, all of those filter down to healthcare as well. And so we want to leverage all those coming in as well and making sure that we can get towards a fully enclosed module. I mean, like a lot of these other movies show, like Star Trek, Star Wars, all these, absolutely looking at the tricorder capabilities. There's a lot of opportunities we see, but it's probably not there tomorrow.
Well, I think you just answered the next question, which was, how long can I stop in until I can stop in on for X-ray on the moon?
Oh, that could be tomorrow, frankly. Our systems are ready. So Adam just needs to put them up in their containers and send them up.
Yeah,
and
we're in.
Yeah.
Louis is asking, has AMOL looked at the work done by Chemical Q Device, which was started by Kevin Kotchak in California?
Unfortunately, I have not yet. I'll look it up after this call.
Okay, we got it in the chat there. I'm wondering, I know you're ready to put this stuff in containers down here on the surface of the Earth, but taking it into space means you're going to go through a whole lot of shaking, and there's a whole bunch of testing involved, and it's got to be pretty durable for that. Have you got to a stage in your development where you're testing to see if it can survive the radiation in space and that sort of thing?
It's funny how now with the accessibility of space, now frequently they're shipping things up there. So our executive vice president of strategy is Drew Feustel. So he's the retired chief astronaut for NASA, probably the most famous geophysicist on the planet, I guess, at this stage. He often talks to me about what life was like while he was the commander of the station. And he refers to like iPads, like they would ship 10 of them up, see how many survived. So to some extent, some of the technologies that we're using here on Earth they might just be put in a box and sent up on a launch vehicle to the ISS to see what works and what doesn't, and kind of forego all of the necessary the standard testing that you do for, say, mission critical pieces of technology that have historically gone through that testing. Other pieces of equipment, we might want to shake up and and test in radiation settings, but for us, it's not all about that. I mean, we're focused as like systems integrators almost for the healthcare system, and a holistic package that includes how do you get it all into a centralized system? How do you communicate it back to the people who can make use of it and make value with that data, and then provide care to the astronauts long term, and then eventually how to turn that into artificial intelligence that can help them be self-sufficient with their care requirements as they get further into the solar system, right? So we keep our eye out for all of those technologies that are shaken, are tested. I mean, even better. But I think it's important for all of us to realize in the space landscape that things are changing, and there's a lot more willingness to just send low cost items on to the space station and see how they go.
You were talking about your energy system too, and I know that's going to be really important on the moon because there are some long nights on the moon, and I keep seeing these pictures of stations on the moon with solar panels, and I'm thinking to myself, yeah, it's not going to work for the whole lunar orbit. So is that something you can also use down here, those kinds of systems?
Oh, 1,000%. 1,000%. It's a core part of a clean energy transition for Earth. What we're seeing in the development around nuclear technologies, and kind of modernizing their manufacturing. So we're scaling them down. We're making them more efficient to produce, more readily accessible to maintain, safer, all of these things, so that you can start producing them at mass. There's a huge, I'm trying to remember the actual number for the projections for nuclear energy requirements coming in the next 10 years, and in general, like the need for energy that Earth is sort of consuming, and at the rate it's growing. We need more energy sources. We need more clean energy sources. Solar, wind, they're all great. Hydroelectricity in Canada is fantastic. It doesn't extend everywhere. You look at special conditions like the Arctic, where you can't rely on those natural features. And the only viable long-term heat and energy supply that is carbon free is these micro reactors. So 1,000%, this is a great example of how innovation for space is helping to drive down costs of a system that is desperately needed on Earth. And so the Canadian government has been great for us in helping that along, and the agenda of to the benefit of all humankind.
Great. Amol, Rocky here is saying, what TRL level are the imagery devices? You mentioned they were ready to go tomorrow. Have they been field tested, etc.?
Oh, absolutely. We're TRL 9. We've got Health Canada approvals. We've got FDA approvals. We've got European approvals. We've got multiple sites around the world that are already using it. That's why we've got a lot of clinical data backing up everything I've mentioned to date.
And for on-Earth applications, what will it take to make these, or systems like these, widespread in remote communities?
Frankly, I think it's awareness. There's nothing holding us back in terms of deployment except for people's awareness, working with the governments. If you look here in Canada, and Adam could be more of an expert in this area than I am, it all falls under the federal government. And so maybe Adam can probably shed more light on that.
Yeah. More and more Indigenous communities are being given control of their own decision making. So their own health spending, their own everything. So it is a lot to do with awareness. But I mean, we also have to recognize as a nation that inequity has been pervasive across Indigenous communities, and so there's always a little bit of skepticism when introducing something new. It's important to build trust. It's important to co-develop these things. Like one of our of our long-term goals. And our chief scientist is has First Nations background as well. He's of First Nations descent. So he's done a lot of work in the Arctic, building infrastructure there and serving on several important boards for the region. You know, he advocates for co-development, and we're very serious about that. When we're looking at our health containers, we're not looking at placing it in there and delivering care. We're looking at working with the communities to figure out what services are needed around the health container, creating an economy there around it, helping to lift up the communities, and not just for healthcare purposes, but for economic purposes that can then serve to sustain the communities long term, while also ensuring the longevity of the technologies that we're putting there, and not just something that goes and helps and for a minute and then is forgotten about, right? So we want to, that's a huge part of it, is ensuring the longevity of whatever you're, and working with them to ensure the longevity of what you're placing in Indigenous communities.
Wonderful. If there's any, just to remind everybody, if there are other people out there with questions, don't hesitate to put them on the chat, because we'd love to answer them for you. What else do you think we should know about this going forward in the next few years? I mean, everyone's talking about getting back to the moon. How, is this something that NASA is working with you to achieve, or are there other space agencies that are interested in this as well?
Yeah, you know, NASA, we're in regular contact with NASA. They support a couple of our projects, kind of through the Canadian Space Agency, as allied agencies. That's how these things usually work. You know, I would say the return to the moon is happening. We're seeing progress on a month-to-month basis. You know, we had the big milestone a couple of months ago of the first private American agency or organization landing on the lunar surface. Tipped over after, but you know, let's leave that aside for now.
Not easy to do.
Still a great achievement to get there and put it down and you know, have all systems go. So you know, we're seeing more commercial interest in it, but honestly, I think what's really going to drive the space economy is probably the commercial space stations. Once you get private industry in space, it becomes an economics equation, right? They're going to be looking for resources in more affordable ways, and shipping resources from the Earth and competing with gravity to do that is just not the most economical way, and that's going to help drive resources from the lunar environment. It's going to start to build out an opportunity for healthcare, as more people who are maybe not the healthiest astronauts are starting to take trips into space and spend time on the stations. All of a sudden there's going to be a need for more care. So, you know, as we see those come online, probably over the next like 5 to 10 years, I think we're going to start to see a big shift away from just government contracts and more towards commercial incentive to do this. But the government agencies have been a huge part of making sure that the upfront risk and the upfront capital are things that industry can work through, you know, on the way to building that long-term commercial economy in space. Yeah.
We have someone asking if astronauts will eventually be using these health containers for training in lunar-like environments on Earth.
Yeah, I mean, it's certainly something that we would like to see. So I think, you know, you see a lot of analog missions already on Earth, and analog astronauts, you know, spending a year at a time in isolation to try to understand what life on Mars would be like. They do a great job of trying to replicate systems, and yeah, it would be great to see one of our modules on one of those analog missions on Earth in preparation for life in space, and then eventually at the space agencies as well, is something that the astronauts train on. That'd be great.
Amal, Louis R is asking, is neuroimaging a part of your R&D?
Not immediately. It's, as I mentioned earlier, we're looking at building more of a pseudo 3D system, and that's when we'll be looking more neuro style as well. So the skull, the way it is, you got bone right across all across the soft tissue, so it makes it tough for our spectral to work as well. But that's when we need 3D capabilities, and that's our next version of our product.
Is that coming soon?
It's coming.
Someone is making an observation here, Victoria. A great way to get funding for these initiatives would be to target defense shipping companies with ITB obligations in Canada.
I guess that's for me.
I guess.
Yeah, yeah, that's true. Defense has, I think a lot of the growth of the industry in the last few years is because of this renewed interest, not just like across three areas. So there's scientific, commercial, and defense. And as the three of them converge in low Earth orbit, we see, defense priorities shift, like with the war in Ukraine and satellite infrastructure being put into low Earth orbit by non-friendly nations and non-cooperative nations. It becomes more and more important to kind of build infrastructure that can protect our interests as a country. Defense there, it's a huge priority for them. The ITB credits are a great way to access that if they're available.
Absolutely. We're also looking at those, and that part of that for us comes to some of the inspection side. A lot of these military or defense side, they're looking to build stuff, and as they're building things, we're trying to use our X-ray capabilities to allow them to get better quality out as well, or find defects before they're actually in the field.
Right, and apparently that was from Rocky, not Victoria. From Henry, can speakers elaborate on applications in remote sites on Earth, Arctic, Antarctic, and ships on the seas?
You want to go first, Mo?
Well, yeah, for us, because we are just like another X-ray system, those are all areas for us. Like remote is so interestingly enough, maybe just back half a step. When Kareem, my co-founder, and I started the company, we actually focused on social rural health, social innovation, and looking at the rural parts of the world where we know access to health has been a challenge, or advanced healthcare. And imaging is actually one big part of that. When you don't have imaging in the rural parts of the world, and that could be, as you said, in the Arctic, in the rural parts of North America, even, rural parts of Canada, frankly, let's be clear, 4 hours out of Toronto, you have almost sometimes no imaging. And the same extends to ships, and we've looked at even talking to cruise ships. They have X-ray systems as well. So when you're out in remote parts, you need better imaging. And so that's actually why we started the company, is initially to provide better imaging in the rural parts of the world. And of course, now that extends, of course, to off world as well.
Yeah.
Fabulous.
Yeah. We see the same thing. I mean, there's not a single MRI or CT scanner in northern Canada, in the Arctic, in the Northwest. Sorry, I should say in the Northwest Territories and Nunavut. So anytime they need imaging, they're being extricated from their communities, from their support networks, at great expense to the Canadian health system, transported for weeks or months at a time, often to Edmonton or Calgary or somewhere that has the capabilities that they're looking for. So I mean, yeah, imaging is a huge part of it. In terms of ships, you're at sea. You need healthy for extended duration and long missions, much like space travel. There's a lot of analogies there. I think as a really good parallel to draw.
Just checking to see if I've gotten all the questions here. We've got some great stuff coming in here. Questions have stopped, they say. People have run out of things to ask. You've completely educated them.
It's done. We did it.
We did it. Let's go. Let's now go deploy them.
Yeah.
Well, yeah, like let's get that stuff out there because, like you've been saying, there are all kinds of places all over the world that have a minimum of resources, and this seems to be such a great answer to it because, like you said, I mean, you don't have to fly people thousands of kilometers to try to get them to the care. You can take the care to them, and it's right there. So can we have one last call for questions before we let Adam and Amal go? I don't want to miss anybody. If someone has got some last minute thinking they want to squeeze in there. But this has been a great presentation. I'm looking forward to seeing, what you guys do with this going forward. It's going to be amazing to see this stuff in action, and off world too. That's going to be really exciting.
I hope we all get a chance to go off world to see it in action.
Well, you were mentioning earlier about commercial space, and I mean, part of that, if you look at all of the space station designs out there, part of all of those designs is space tourism. There are people that want to go up there, and you were saying people who aren't necessarily healthy enough to do that.
Yep.
Yeah.
But listen, William Shatner went to space. He's not the shining specimen of health. As we see more of that happening, it's just healthcare in space is going to become.
Okay. We've got another really good question. That's what can we do as Canadians to support your efforts?
I think it's awareness. It's just like you guys listening to this is the first step because, as I mentioned earlier, one of our biggest challenges is awareness on what we do and how we're doing it and how we're helping. So the more people to get understand, and then you go talk to your doctors, you tell the hospitals there, you guys need to work with these Canadian great technologies. That's how you can help. And of course, pushing government's not easy, but changing payments and procedures and all that's a different story. But it's just that first step of awareness and getting people to know what we're doing and talking about it in the community and saying there are great Canadian innovations that are making a difference here. And that's what is a big help for us.
I'll take it to this. So historically, a lot of people wonder about the spending on space innovation. That's been it's often a point of friction for governments, for civilians who are uneducated in the kinds of things that emerge from investing in space. And in the public eye, that can create slowdowns, lags, that sort of thing. Canada has all of the key national strengths in order to lead the world in space health, in space mining, in space power, all of these things, all the areas that CSMC is playing in, and that's part of our ethos, is that Canada has a right to lead in these areas. But there's a lot of friction because a lot of people don't understand the benefits of investing in space innovation. So, I think to Amal's point of awareness, I would take it, just extend it to this same theme of go out, make sure people understand that solar panels were invented for space, that scratch resistant lenses, that vacuum cleaners, that carbon fiber, that MRI technology, all of this stuff came from space innovation. And if we talk about it more and raise the awareness, then I am optimistic that it will reach the ears that in power. And we can start investing in it more as a mission-oriented innovation strategy as a country, and kind of like seize our opportunity to lead, because this is the time where what we're doing in space falls right in line with what Canada is the best at.
Well, somebody is asking, Louis again, how much are you making of AI and also quantum computing?
I think every organization, any technology organization in the world right now needs to be making use of AI in various capacities. If you're not, you're probably doing something wrong. And when we're talking about on our resource side of our business, new instruments for resource exploration and identification, tons of AI, tons of data fusion, tons of exploration of quantum technologies and how those can aid in identifying critical, like, rare earth elements and things below surface. So yeah, there's tons of that. When you look at the microreactor, I mean, you're dealing with nuclear physics at the atomic level. There's a lot of quantum considerations that go into that, and then the AI necessary to monitor and control that sort of power source. And then I've already talked a lot about the health front, where long term we need to move a lot of the diagnostic capabilities and health recommendations to an AI platform so that we can deal with lags in communication as we move further into the solar system. I hope that answers the question. I feel like I'm just scratching the surface of where AI comes into play these days. And
yeah, so yeah, we are using AI already. Part of it's already implemented in helping us in some of the products and workflow. We broke up AI into 3 area categories. Really, we see AI in terms of image quality improvements, workflow improvements, and traditionally the way people think about is diagnostics as well. So we're already starting to make strides in all areas for us. Quantum computing, that's an interesting one. No, we haven't started using it yet. I'm sure a lot of people haven't either, but it's definitely something that would make a lot of things that we're looking at in the future as you to get more data and richer data sets. You need faster processing to get faster answers. Healthcare is a great example. Time is essentially life. You take time to get a diagnosis that could alter a person's life. And so how do we get faster? Quantum is sort of one of the ways that a lot of people are looking at it. So absolutely, we need to look at a lot of this stuff in the future.
Tom is asking, are there any remote implementations of any of this, i.e. beyond tests? I think since that you've gone beyond just testing this in the Arctic and so on.
As remote, not depends what you want to call remote. We've got implementations where we did some, it was a urban hospital, but in Philippines. We've done some work now. We're actually about to deploy in Kenya. We're looking at working with some other organizations. So we do take sort of like a double bottom line approach where we're looking at beyond just our northwestern profit lines, but looking at how do we deploy this. As I said, when we started the company, we looked at the social impact side as well. And Grand Challengers Canada, actually, frankly, was one of our first investors that allowed us to push for that. So we are implementing and working with some African countries right now and trying to get our systems out there.
We're moving into the first commercial deployments on some of our technologies. Some of our technologies are much longer timelines. I guess that's just where I'll leave it at this point.
It's coming.
Yeah, it's coming. It's coming fast.
Well, I mean, it'll probably be coming faster. You were talking about getting the word out. I mean, if people get the word out, and there were people were asking what is going to make government spend money, people asking for it. I mean, people saying, if this is out there, why don't we have it? When can you bring this to us? Because we need this. So that's a very important thing. Okay, one more call. Last call for questions. Looks like we're running into people having a lot of thinking here in the background. This has been great. I really appreciate both of you taking the time to put that out there, and I hope that once we get this out there in YouTube land, it'll put the word out and help get more customers and help to more people that need it. Any last thoughts before we wrap this up?
No, I just want to say thank you very much for listening. It's a pleasure to be on these, and I really appreciate when we get a wider audience than, say, my typical audience of doctors and radiologists. And, as I think Bess and I asked earlier, it's awareness. It's about awareness and getting people to know what we're doing. It's about spreading the word in the community, but also engaging. We do talk to our politicians, and we talk to the health technology assessments parts of the provinces and the federal governments. And so, we try to market ourselves in that sense as well. So again, I really appreciate the opportunity to be here today.
yeah, I'll echo that. Any chance you give me to talk about the future of space for an hour, sign me up. That's why I got into this, and I really love being here. And I'll just echo something I said earlier again, that this is Canada's time to lead in space. And if we don't move on it, it will pass us by. So we can't let that happen. Keep talking, tell your friends, they know someone, tell them. And let's keep moving as a nation towards this kind of mission for accelerating our contributions to a very large and emerging economy.
Okay, and I look forward to seeing you guys out there in the asteroid belt, because I do recognize the name of your company there. So it suggests that's the direction you're heading in. All right, well, that's it for our show. Thank you for coming. Space Places. Looking forward to seeing you in the future at other events, and we hope you enjoyed this.